Hi, everyone. We'll be speaking on how to set right alert metrics, which we have learned through our mistakes. We are from ZenDuty, an end-to-end incident management and response orchestration platform. I'm Ankur. I have accumulated years of experience making mistakes, learning from them, and advocating for best practices for organizations setting up their DevOps, SRE, and production engineering teams. Dheeraj will.
Yeah, I am Dheeraj, and I work as a founding engineer at ZenDuty, and I majorly deal with backend stuff, and time to time I also deal with some of the infra stuff. That is why I am here, and I'm an observability thinker, and thanks to great presentation, so it got me more excited on OpenTelemetry. So let's move on to why we are here. So one of the things why we are here is to find what does the right metrics mean when you are trying to monitoring and alerting. So I know it's not that pretty straightforward. So something right is not that simple. So and especially when you are new to Prometheus, new to monitoring, it might take time. Sorry, I'm a bit nervous. So but I'll quickly catch on. Yeah, and learning from mistake. One of these mistake, I'm nervous. So and other thing, come on, who doesn't do mistakes? So we all do mistakes, and we'll go through some of the things, some of the mistakes which we uncovered, and we'll go in deep that. And now for the most difficult part, to answer what does the right metrics mean. So and
okay,
sorry, and yeah, and also to answer the two important questions that finding the right metrics which can answer your P0 incident. So yeah, we tend to configure most of the alerts which answer most of your incident, but there are a few alerts you need to configure to answer your P0 incident, and at the end of the day, it's all about the cost. So is bad monitoring costing you? So and yeah, building a monitoring system is very hard, especially if you are new into monitoring space, and it might become pretty chaotic. So it can't be done overnight. So you have to learn from your mistake and keep iterating. And so we are emphasizing what right alerts are. So right alerts are alerts basically should have an impact. So and should be actionable, should be concise and accurate. So yeah, that's all. And now I'll go through some of the key performance indicators which measure. Some of the key performance indicators which measure your application. So yeah, just to refresh, SLA, service level agreement. So this generally says the uptime of your website. So and SLO, service level objectives for you to meet with the teams. And the most important thing, service level indicators like latency, error rate, and system throughput, which will help you understanding your infrastructure more better. So yeah, this is another slide. Fun fact that Google Compute says their SLA is 9.95. So it means Google Compute can go down for 4 hours 20 minutes. So if you have some bad alert configured, maybe yeah, that might become pretty chaotic. And so yeah, so how SLOs are calculated? So suppose if you see an API where you have 1% of error rate, then that means your SLO will be 2 nines. So yeah, this is how you monitor your SLOs, and you can see some of the monitoring stuff. And this is another slide where you can see over the 30 minutes what was the availability of your pod and budget. Yeah, error budget remaining, that is almost 6 hours 48 minutes. And yeah, I hope you are familiar with this. So we as a developers tend to see this a lot on our daily to daily basis. And yeah, oops, I think we just got alerted. Maybe I'll hand over to Ankur.
So thank you, Dheeraj. So moving on, we'll be going through some alert configuration with scenarios which we collected through our own experience and also by talking to a few customers. The first and foremost, which should be there, that having no alerting at all could be the biggest mistake which we can make when we are already monitoring and collecting a lot of data. we don't want our team members to keep looking at the screen, looking for those anomalies, doing 24/7. If we set the right metrics, we can actually use the time of our teammates in a productive way, because who does want to actually look at the screen and look for patterns if we have machines to do that with the computing which we have, right? We have also done some research by talking to 20 organizations of different sizes, and we have observed that they get on an average of 200 to 500 critical alerts over a month. If you're missing that many alerts in your organization, that means that many instances will come where your team member or your company will be clueless or takes more time in actually resolving those incidents, which will breach your SLAs and SLOs. The second would be, even if we start setting up alerts, if we don't actually set enough alerts, we'll still fall in the first category, where either we do have some alerts where we are getting alerts, but the scenarios where we have not set the alert, we still have to do the same thing over and over again. Third would be setting up too many alerts also. I think we have already covered, some of our friends who have covered talk about the alert fatigue. That happens because of excessive noise when we set too many alerts. It could lead to alert fatigue also. It's like creating a Slack channel where you are bombarded with all the alerts, and with all the noise, you will end up muting that. And when a critical issue will come, you will miss that. So setting those kind of alerts will have no point, and again leads you to breaching those SLAs. I'll cover a few examples on how a right alert will look like. This is one example which we have seen. So we need to keep track of our node versions at a kernel level. So this could happen. I know when people are setting up their nodes, they actually finalize what kernel version they are using, right? But when you set up node refresh, some people will be setting up by 2 weeks, 1 month, or maybe quarterly refresh, right? There might be cases when your kernel versions will get security patch update, which have kernel updates as well, which will lead to these kind of kernel version mismatch. And when these things are not tested in production, this will lead to, the extreme could be a downtime. But all in all, if you have an alert set like this, you will be able to understand before it happens. Next would be high context switching. What context switching is, where your CPU switches from one process, or maybe the thread count are moving very frequently within your applications, right? So when you are early in stage of actually monitoring, you may not understand what kind of traffic you're getting and how your application is responding to these kind of requests, right? So you need to set a threshold for these alerts where you can understand what number should be there, so that which will define your configuration for your pods and replicas, like the memory which you want to put, the auto-scaling metrics you want to put, once you get to the number. In a mature system, ideally this should not be hitting that alert, although you still should set a alert for that in case of a very high traffic which you are not expecting. It's sometimes good, because if you are running an e-commerce company and you start getting a lot of traffic, a lot of orders, your company will be very happy. But again, when you don't have the alerts, and if you are not able to fulfill those orders, it will lead to loss for the company. Okay, so this is a suggestion, yeah. The other would be, this is related to our HIPAA. When we are setting up HIPAA, we have our min numbers and max numbers, right? So this is related to minimum number of pod. Although when this kind of alert will come if your minimum number of replica and your desired capacity are equal. Yeah. So you would want to keep a track of when you're hitting that minimum number. And when you set this alert at a desired capacity equal to minimum number, you will get a lot of noise. So the ideal way would be to actually keep your desired capacity slightly higher than your minimum number. But keep a track of your minimum number, replicas hitting the minimum numbers. The next HIPAA alert will be for the maximum capacity. So if you see, we have already set an alert for our maximum HIPAA capacity, right? But there's something wrong with that. It's like if you get alerted for HIPAA reaching the maximum capacity, you're already too late for that, right? Because at that particular time, when you're already at a level where your HIPAA reached the maximum capacity, and you don't know whether the next step would be to actually get more traffic or maybe it will be reduced, right? There's nothing you can do here. So the ideal way would be to set it in the right way. We did our research and we have configured it as 70%, but yes, it could actually vary from 65 to 75% based on how fast your scaling happens, right? But you need to keep it under 80%. It's funny to look at it, but you need to keep a track of your Prometheus replica going lesser than the minimum value which you have set, right? The reason being, when you're getting too much traffic and your Prometheus is scraping too much data, right? If you don't have enough replicas working for, pods working for scraping that much data, your alert manager will get all the data slightly delayed, which leads to those alerts getting triggered in a late manner, where the chaos would have happened and you would have come in later on. I'll hand over to Dheeraj to cover next.
Yeah. There is another metrics called container CPU usage, which the metric simply says that your CPU usage is above a certain threshold. For our case, it's 80%, then you'll get alerted. But a few things to note down over here that based on our R&D, we configured our threshold at 80%, but it depends infra to infra. And one other important thing to look at that if you have come across this alert after a release or maybe a change in infra, maybe it's better that you roll back so that before some catastrophe happens. And same thing, high memory usage. So it's the same as CPU usage. By our R&D, we came up with a 75% memory limit, but it depends from infra to infra. So yeah, rolling back would be a better option if you have released something. So OMM kill, this is an interesting thing where generally you see OMM kills when your CPU is, when your container runs out of memory, but that's not always the case. So one interesting case would be that one of our microservices used to dump a lot of tasks, so it was written in Python, so Python and garbage collection. Yeah. So now it used to increase the space complexity way too much. So our solution was not to increase the desired memory limit over here. It's just patching the code so that you can have a better garbage collection on that particular microservice. So, and the other thing would be container restarts. So yeah, these 4 slides which I talked about are pretty much related to each other. So again, sometimes container restart may happen because there might be OMM kill, or maybe there is an internal process that killed your metrics, but there can be cases, unavoidable cases where, so if I want to give an example, suppose in case of a broker and a worker terminology, so if the broker doesn't give any AG back to the, if a worker doesn't give any AG back to the broker, maybe in under 30 minutes, so you would get a restart. So, I mean, this is the unavoidable case, but this is actually an unavoidable case. But yeah, one workaround for this particular problem can be that you separate the jobs which you know will restart, and you separate the containers for the jobs which doesn't restart. So you can simply silence the containers which might restart so that you don't have to worry about container restarts, but still again you can be sure that the containers which are not supposed to restart, you can get alerted for that. So other thing would be tracking your 400s. Yeah, tracking your 400s is a good thing. It's like a warning alert just to measure efficiency and performance of your application. But again, what's wrong with the configuration? Often you tend to see 4xx has a 429, and 429 are like pretty obvious if you are an ingestion engine or something. So you usually tend to see so many 429s. So if you have configured your 429s along with the 4xx, then you might see this alarm too often. So the correction would be, yeah, correction would be changing the equation where you exclude the 4 to 9s from your 4xx. And so by doing this, in our infra, we have reduced the noise by around 82%, where we can only cater to the 18% of the warning alerts due to this 4xx. And now you must be wondering that we removed 4 to 9s, but there is another tricky way where you can monitor your 4 to 9s. So one thing would be this alarm is just to monitor your 4 to 9s, but yeah. So in this case, so tracking your 4 to 9s are pretty important, and one of the cases would be that usually 4 to 9s tend to take a lot less time compared to other status codes. But if you see in this particular alert, you see that if your 4 to 9 takes more than 5 seconds, so that means there is something wrong, and so you might have to quickly look into your Redis or your DB or something else where your 4 to 9s are managed. And now 5xx are pretty bad in your service, but yeah, we are developers and we tend to make mistakes in the code. So it's a very good thing to keep track of your 500s. And now we explained a lot of metrics over here, but there are a few cases where these metrics doesn't help you a lot. So you might need application-specific metrics. So I'll hand over it to Ankur so that he can explain what are the application-specific metrics and how can you debug an issue based on that.
Yeah, thank you. So while we can set alarms on number of the error codes which we get, right, the 4x's and 5x's. But if you're already getting all the 2x's and still you could lead to your bad performance with the application, right? So for that, we need to actually keep our latency. The best way would be to actually keep an eye on your P50, P90, and P99s. Ideally, I would not be happy with the P99, which we have shown here. But in some scenarios, this will be, it has to be the case-to-case basis where you have P99 of this much as well. This is one of the examples which we have seen where you can see that our P99 was badly hit for a given 7 to 8 minutes. But if you see, it came down automatically by itself, right? Nothing was done there to actually fix it. But to do a post-mortem on it, we actually found out something pretty interesting, right? To explain that, I'll actually take you through two things, anomalies related to our application metrics. One is request backlog. It depends on, even if you're getting too many requests, your container will show your CPU is not spiked, the memory is working fine. Because at the time of running, they are handling all the requests within the given range, right? But still, there could be some requests which are still in the backlog because your worker tends to keep them in the queue. That's how the architecture is, right? The other way would be to have a busy workers, where your workers are, the busy worker could be because of your application code not being optimized to perform all the tasks at a given time frame, and that's what leads to the worker being busy. The other metric you see, a request backlog could actually backfire like that. The spike, where for a certain time frame, and we actually started debugging for the above case, we found out that it was because of the backlog and not related to anything else. A busy worker would lead to this. So what we found out was that this was because of in our case, it was because of a new patch which we released to the application. It could be another reasons also, where the patch was already there, but you were not getting that many requests from the right resources, right? So, but you need to keep track of all the releases you are doing based on that. So we actually rolled back very quickly, and we were able to actually fix it in very less time. Yeah. So moving on to the next metrics, like we actually monitored number of Prometheus replica, which is important, right? The other way to keep a track of actually alert manager being connected to Prometheus. If your alert manager is not connected to Prometheus, the alert manager should alert immediately because we'll not be getting the new data if this is the case, right? And then something needs to be looked up. That why is it is because of the network layer, or maybe there is a problem with the alert manager. The next would be, we need to keep track of, because we know with Prometheus, it can sometimes go in a direction where the scraping needs to be really high, right? But to scrape the right amount of data, it could be because your settings require those much data to be scraped. But if the Prometheus does not have enough resources to scrape that much data, the way the scraping is scaling, your alert manager will still get delayed if you are not keeping a track of the scraping data which is being done. Also, it's good to actually keep track of the scraping data to keep the cost under check so that you don't get heavy bills from your cloud after a month because this alert was not set. At least you should know how much bills you'll be getting to keep an eye on that. Oh, sorry. So, but why are we emphasizing so much about the math related to just alerts, right? Because we can always put, from a company perspective, we can always put few extra people to actually work around the math or maybe look at these screens automatically, right? So we did some very basic math for a very small team, not even a very big team, and that's what we found out. So if you see this cost is based on some region of a particular cloud. So just to give you an example, so you already know our per GB cost for our NAT, and when you're setting up a NAT, you will be setting up the multiple region, multiple HA for NAT, right? So 6 NAT will be required. For a given team of, we assume the given team of 500 people, we'll have 30 engineers who will be actually using consuming the data for the Prometheus which we are getting. And this much average monitoring bandwidth consumed per person every day. So we think this is very less, but this is the cost which we'll get when we actually multiply everything. This is $59,000 roughly, right? But we did some more math if we actually set the alerting in the right way with well-configured alerting and metric monitoring, and also through Prometheus scraping, storing the relevant data, not storing everything. If it is not needed, it's always avoidable because both the things are there. When you're transferring more data, you are taking more bandwidth also to transfer the data, which leads to latency. And the other thing could be your alert manager needs to get alerted for those data as well. So for that, we have been able to identify that if you set up a right alerting, the cost save from the data transfer perspective only is 35 to 45%. In that particular case, the cost was 26,600 compared to 59,000. Great. So I hope after this we'll be generating only alerts that require attention and also keep learning from our more mistakes. We would be happy to. But how do we approach incident management here for a cleaner solution, right? This is one of the examples. One of the architecture, I think we have already seen an incident happening here an hour back where our display was not working. The production team was able to handle the incident very calmly, while the stakeholder communication was taking care and keeping the audience engaged. Yeah, we have almost done, yeah. Okay, so if you see, the error monitoring is set up with the right communication channels, with the APM, and the real stakeholder and the owner of the team. This is how incident management with everything with the response side looks like. Thank you. You can always contact us for the collaboration. We'd love to actually see what mistakes you are making. We'd love to include them or maybe talk about that and also learn from your mistakes. Thank you for listening. Yeah. Okay.
All right.
One more thing. You can actually go to this to actually, this is something which we found out. This is not written by us, where these are really cool Prometheus alerts. You can go through that. It's an extensive list also.
And we would love to discuss on community.zenity.com if you have any queries.
All right. We have 1 minute for questions, so you can ask one question, basically, if anyone has a question. Okay. Seems like we are at time anyway, so let's, one more round of applause, and then we'll start with lightning talks.